Okay, today we're going to go on. We're going to do the product and the quotient rule. I will show you how the book puts the formula, and then we'll talk about the formula like in words, okay? So you can choose whether to put like what the book exactly would have or what I would have. When we get to quotient, I write it a little differently than the book because I phrase it in terms of like the product. So product is used for products. Before today, we had to multiply out and then do each individual term. Now we're not going to do that. We're going to do the product without multiplying it out. Quotient is for quotients, for division problems. Before, we had to divide each term by the denominator, correct? Now we're not, because before the denominator was like a term. Well, what if the denominator is a polynomial? We have issues, right? I don't think we want to do long division 5 times before we can do, no. So we got 2 rules. These would be something you need to know. The proof is underneath. Please do not write the proof. Just listen for a second. Okay, the product rule. The product of 2 differentiable functions, f and g. So that means you can take the derivative of each one. Okay. Moreover, the derivative of f times g is the first function times the derivative of the second plus the second function times the derivative of the first. That is the words. It's the first function times the derivative of the second plus the second function times the derivative of the first. I will sometimes say it backwards because it's addition and multiplication. Does it matter? No. Okay, so we have d dx of f times g is the first times the derivative of the second plus the second times the derivative of the first. I never write it like that. I write f prime of x, g of x, plus f of x, g prime of x. That's how I write it. I don't know why, but that's how I do it. Is that any different than what I have? The derivative of the first times the second plus the first times the derivative of the second. Underneath is just the proof, the long way. Okay? I don't think you want to do the long way, do you? No. I have it there so you can see it. It works. I don't want to go through it. Okay. So this is it. You need to know it. You need to love it. You will use it about every single day from now till the end of the semester. Okay? All got it? Okay. So the product rule can be extended to cover the products involving more than 2 factors. So this isn't really necessary. Just know it happens if I have f times g times h. So the derivative of the first times the other 2. The derivative of the second times the other 2. The derivative of third times the other 2. And if I had 8, 9, 10, I would just go through all of them. Okay? It's just like composition of functions. So an example of that, for instance, you don't have to write it down. Just pay attention, please, that I have the derivative of x squared sine cosine. So I have x squared sine and then cosine. Yes? So the derivative of x squared is 2x, then sine cosine. The derivative of cosine is, derivative of sine is cosine times the other 2. The derivative of cosine is negative sine times the other 2. They then, really weird though, they grouped these 2 and factored out a x squared. And so they had cosine squared minus sine squared, which is not 1 because that would be cosine squared plus sine squared would be 1. So you will learn you want to stop when it's easy to find a slope. Because remember, derivative is the slope function of the function, yes? So you want to stop where it's going to be easy to plug in a value to find the slope. That's where you stop. Is factoring going to make that easier? Yes, because you don't have to multiply by x squared twice. You just multiply by x squared once. So those are some things you're going to learn. You're going to, at first, it's going to be like, when do I stop? And I'm just going to say, well, make it easier. Make it easier to work with. Make it easier to look at. Okay, because we want to keep our brains in our heads, not running out the door. Okay, for example, find the derivative of 3x minus 2x squared times 5 plus 4x. So again, it's f prime g plus f g prime. I left out the x's, but in short, that's what it is, correct?
Yes.
So f g. So h prime of x. So the derivative of 3x minus 2x squared. What's the derivative of 3x?
X cubed is 3.
3. Because 1 times 3 and then 1 minus 1. Minus
4.
4x cubed. Because you have just, oh, no, not cubed. 4x. Not cubed. Okay. Times the second. So just 5 plus 4x. Plus first
Plus 3x minus 2x squared.
times the derivative of the second.
4. 4.
Yep. And now I have to distribute and combine like terms. So you do it and I do it. We better get the same thing, right?
Okay, how do you get the 8x after the 15?
Because it's 12x minus 20x.
Oh, I didn't do it. I just wrote it out.
Oh, you didn't combine like terms?
I got what you
not
wrote.
yet.
'Cause I'm just so good at math. What did I do?
Did you find it, Jaden?
Well, I forgot, like the 5 plus 4x, I didn't have the other x in there.
Now, I typically will always write this 4 in the front because I can't stand it in the back. But you'll start doing those things kind of automatically. I usually do f prime g, g prime f, but I just mix it up. Do all sorts of fun stuff.
Do you do anything after this?
No, if it asks you for the slope or the equation, then yes. But we're going to start just with
Like, what did you
derivatives.
do? What did I do?
Probably your math wrong.
I don't know.
You want me to go from the beginning? What did I do or what?
Oh,
I was about to ask, wouldn't it be -4 and then realize that
I think I distributed it wrong.
You should have 15 plus 12x minus 20x minus 16x squared. And then plus 12x minus 8x squared. So 12 minus 20 is 8. Negative 8.
Oh my goodness. It's gonna be a long day today.
Okay, we good?
Yeah.
Okay, so find the derivative of 3x squared sine of x. So what's f? 3x squared is f. And what's g? Sine of x. Do you need to know what is f and what is g? Yes. Okay. So y prime. Tell me what to write.
It would be 9x.
Nope, 6x.
X.
Oh yeah.
So just 2, not squared, just 2.
And then sine x.
Then sine of x.
With g, it would be 3x squared cosine.
So it would be 3x squared cosine of x. Can I combine anything?
No.
No. Can I factor anything out if I want?
3x.
A 3x. Kind of made it simpler, not really, right?
Where'd
6x go?
Oh. Did it make it easier? Kind of, not really, right? So you have to make a judgment. What you would like to see happen. Okay? There are certain things that you have to do, like you can't leave a fractional exponent. Well, you can't leave a negative exponent, definitely,
I
right?
like this.
Hmm?
I like this.
You like this?
This is easier than the other stuff.
Okay, this can't be easier than the other stuff because...
It makes more sense in my head.
Okay, good. I'm like, it can't be because it uses the other stuff. Okay, so now I want the derivative of 2x cosine x minus 2 sine x.
It would be...
So, just a second. So, I'm going to use, I have an f and a g here, yes?
Yeah.
So, I'm going to do the product rule here and then minus just whatever that is. We can combine rules. You can do a product, quotient, chain, all in one problem. It's just what you're presented with.
Making stuff up again.
No, I'm not. Nope. Nope, nope. Okay, so we got to do the first thing.
2.
So y prime,
Match the f and match the g.
what?
She just picked it.
Yeah, why can't the 2 sine of x?
Because this is completely separate. This is product. The rule is product.
Oh,
So they're multiplied.
Because they both have 2 different x's?
No, it's f and g because it's 2x times the cosine of x.
That's what I mean.
There's two different
products.
there's two different things being multiplied. There's two things, right? There's two things being multiplied, so that's f and g. Now you can make a g and f, but the negative 2 sign cannot be because that's completely separate. It's a separate term.
Yeah, we don't talk anymore.
Okay, not yet. So then the derivative of 2x is 2, so 2 cosine. Minus, why is it minus now?
Because it's negative sign.
Because it's a negative sign. And then 2x sine of x, right? Now we do this derivative. So what's the derivative of negative 2 sine?
I don't know.
What's the derivative of sine?
Negative 2 cosine.
Negative 2 cosine.
And then they go away.
Can we? Yes, they do. They zero out. So y prime equals negative 2x sine of x.
Yeah, where did you get that from? The 2 cosine x and
The,
negative 2 cosine
I have
x.
positive 2 cosine
I
x.
thought you combined them.
Yes.
Oh, okay, never mind, yeah.
Okay, the quotient rule. So the quotient rule just says if you have two differentiable functions being divided. Okay, quotient means division, yes? So d dx of f divided by g. F is just the numerator, g is just the denominator. Okay, numerator, denominator. So I don't write it like this because what did they do to the order compared to? Because we just wrote, we had the product was f prime g plus f g prime, right? So what'd they do? Right here. They flip it. Why? There's no reason, right? So you take the derivative of the numerator times the denominator minus, now think, product is multiplication, which is repeated addition, yes? Quotient is division, which is repeated subtraction. So that's how you can remember the plus and minus. Okay, so the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator over the denominator squared. See how I took the x's out and it kind of helps? Now, why can't g of x equal 0? Because it's on the bottom. You can't divide by 0. Anytime they put that qualifier there, they're just stating the domain. Does it change the problem any? No, it's just stating the domain. Every student from here until the end of time will be freaked out every time they see that semicolon because they think it means something. Other than you can't divide by 0 doesn't mean anything. No. Okay, so this is that. Remember, you're supposed to be using a different colored highlighter to be highlighting all your rules, correct?
Different colored pen.
Okay.
It's red.
I think I would definitely use a highlighter. And not red.
Pen.
Okay.
Both red.
Am I good? Okay, so here's the proof. Now, this is why we don't do it the long way. Look at this.
I would rather not. I'm confused. What's the long way?
The limit way, the limit method.
Oh.
Okay. So where we did the f of x plus h minus f of x over h.
That we all failed on the test, the long way thing?
Yeah.
Okay.
Okay, so now we're going to do this. So the quotient is derivative of the first times the second minus the first times the derivative of the second all over this, I'm saying first and second, numerator, denominator, right? Should you write that every time you use it today?
Yep.
Yes. Okay. So y prime equals, well, the derivative of 5x minus 2. 5 times x squared plus 1.
Oh, you bring that one up?
That's g. F divided by g.
Why are you minusing?
Because it's the formula.
Never mind.
Because it's quotient. Quotient's division, subtraction. Okay, now the derivative
2x
2x
times 5x minus 2.
times 5x minus 2. All over x squared plus 1 squared. Now, do not multiply the denominator out ever. Hopefully you can reduce.
Yeah.
Maybe you can't, maybe you can, but don't multiply it out. Ever. Because if I had to plug it in, it would still be easier to plug it in factored, correct?
How'd you get the x for the 2? 2x and then the 5?
Because,
Oh, so you do bring the g from the bottom up?
yeah, right here. Derivative of the numerator times the denominator minus the numerator derivative of the denominator all over the denominator squared. So let me write it this way. Okay. So I have numerator, denominator Yes? So, the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. Does that help?
I have that written down. It's just so I just multiply the denominator times the.
That's what this means right here. Is to multiply the two.
Well, 'cause it was F
I'm
G,
I'm
so
talking
you're
about
putting
like
the
the
G up in there.
denominator to the top. I just multiply or do the square to the top.
Okay, so I'm going to do it again, and you tell me, you stop me. Okay, so the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over the denominator squared.
It's just the x throwing me up there because the
Which x?
in the numerator 2x and then you put in the thing since
Okay, so I'm putting the derivative first because the derivative is one term. So if I followed, does that help you?
Are you confused how she like gets the 2x?
yes.
This is derivative of x squared.
The derivative of this, because it would be 2x plus 0.
Cause like I don't know.
Because the
So-
derivative,
So I'm just moving it up.
yes, because the formula is
I'm not
f prime g minus f g prime over g squared. Or numerator, denominator, numerator, denominator, denominator squared.
Do you know how we got the 5 for the first one?
I thought it was just the 5 already there.
Well, the derivative of 5x is 5.
Yes.
Okay. Okay, so now we're going to distribute the numerator, but not the denominator. So I have 5x squared plus 5 minus 10x squared plus 4x, I think. Okay. So that gives me 5x squared plus 4x plus 5. And can the factors of 25 add to 4?
Oh wait, what? Can back,
Oh, that's not even right. Never mind. Okay, don't even.
were you combining them?
I was wrong. Because it would be negative. It'd be negative 5x squared plus 4x plus 5. Yes?
Yeah.
Okay, so I'm looking at, can I factor the numerator? Even if I could factor it, I'm not going to get an x squared plus 1, am I? No. But I should always look. The factors of negative 25 aren't going to have a difference of 4, are they? No, because the factors are 1 and 25 and 5 and 5.
Hold on.
So then we're done.
So we leave the bottom if we can't do anything with it?
Yep.
Just,
Just leave it. Because think about where would you like it to be if I ask you now for the slope. You'd like it right here, wouldn't you?
yeah.
I mean, I would rather plug into this denominator than the numerator, wouldn't you?
Yeah.
Yeah,
Okay.
Why is it negative?
because it's a negative 10.
Plus 5.
Okay, now I won't write it like this any longer, guys. I write it 2x. Doesn't this look better to look at?
Yeah.
And can I move these two around either way I would like them?
Yep.
Because it's multiplication. Okay. Okay, so now I want the equation of the tangent line at negative 1, 1. So this does not come into play until I'm done, correct?
Okay.
Okay, so we're going to write this correctly first of all. F of x equals 3 minus what?
1 over x.
But we're not going to write it as 1 over x. We're going to write it x to the
First.
negative first.
Yeah.
Let me write it. First of all, you're going to write your fractions up and down so you can see them, yes? Okay, and then we're going to write it as 3 minus x to the negative 1 over x plus 5. Why am I making that x to the negative 1?
Makes it easier on
Because
us.
there's a negative and that's the...
Well, the negative doesn't have anything to do with it. The negative 1 has to do with bringing it from the denominator to the numerator. Now, we could use the quotient inside the quotient, but I don't think you want to use the quotient rule on x. Do you?
No.
That seems silly. But you will sometimes have to use the quotient rule in a quotient, which would be, it's a lot, but it can be done. Okay, so f prime of x is the derivative of the numerator. So 0 is 3, right?
Yeah.
So then negative 1 times 1, negative 1 would be 1, but it'd be x to the negative 2.
Yep.
X plus 5. So the derivative of the numerator times the denominator minus, well, the derivative of x plus 5 is,
X squared. 1.
it's just 1.
Oh, yeah.
Yes?
Yep.
Okay, so it's 1 times the numerator all over x plus 5 squared. Okay, so we got some work to do. Can't leave negative exponents. I'm just distributing, right?
Well, before we distribute, can we take out 1 over x plus 5?
Nope. Because the x plus 5 is not in both terms of the numerator. Because this is one term, and this is another term. And if you cannot factor it out, you cannot reduce it out. And it's not in both terms. Okay, all over x plus 5 squared.
Wait, how'd you get x minus 1? Oh, okay.
Negative 1 times negative x to the negative first would be positive x to the negative first. Yes? Okay. So we've got negative exponents, and we have a lot of negative exponents, and that's not okay. We can't have any negative exponents. Got it?
Well, I didn't put it right.
Why is it 1 right there?
Because the derivative of this is 1. Okay, so division, well, okay, so factoring is division, yes?
Yep.
Yes? Okay, and when we divide exponents, we subtract, correct? Yes? Okay, so I need to get all the negatives out of there.
You got them all on the bottom.
I gotta get them all on the bottom. So I need to think about what thing I'm gonna factor out that's gonna make all of those negative exponents positive.
X to the negative 1.
Well, negative 1 would make the negative 1s positive, but it would not because we'd be subtracting a negative 1, so be adding 1. but it wouldn't be making the 2. So we have to go with negative 2.
Okay.
Okay, so we're going to factor out x to the negative 2. So when I factor out x to the negative 2, that means I'm dividing, yes? When I divide, I what? Subtract exponents. When I subtract a negative, I add. Got it? Okay, so I have x to the negative 2. So it's going to be negative 1 minus a negative 2, so that would be 1. And I'm only showing you that for today, because this would be minus a negative 2. Okay? And then plus 5 minus a negative 2 would be x to the 0, which is 1.
So you
Wait.
need 5?
Yes,
If it's minus, why are you adding?
because we're factoring is division. And when you divide exponents, you subtract. So you're subtracting a negative 2.
So it makes it a plus.
Yes. Okay. So now this 3 has an x to the 0, correct?
Yep.
Yes?
So now it's okay, wait, so does that mean the 5 is just 5? Like there's no x after this?
Yes, but I'm just showing you, I'm showing you an extra step than I would normally, because it'd be x to the 0, which would be 1. There is an x. There's always an x, whether it's to what power.
3x squared.
Okay, so then we minus a negative 2, so it'd be 3 negative 3x squared. And then we have minus a negative 2 again, so plus x. All over x plus 5 squared. Okay, so now this negative 2 brings this x down to the denominator. So it gives me x squared, x plus 5 quantity squared. X to the 0 is just 5, correct? Yes?
Yep.
So I have negative 3x squared plus 2x
What?
plus 5.
Yep.
So that's negative 3x squared minus 2x minus 5. Correct? Hopefully you guys are still going down.
Yep.
Okay, can I factor the numerator?
You can.
Factors of 15 that have a difference of 2.
5 and 30.
5 and 3. So this factors to 3x minus 1 and x plus 5.
You still need your negative in the front.
Yes, I still need my negative in the front. So now, Riley, what can I factor out?
Your 5. X plus 5.
I can factor out 1x plus 5 up here and 1 down there. So my final answer is negative 3x minus 1 over, I'm just going to leave it x squared times x plus 5.
And then you have to do your negative 1 and 1.
Now, this would be f prime. We don't have to do both. We just need to do the x, right? So it wants the equation of the tangent line, so we have to find the slope. So m equals f prime at negative 1. So we plug in
3 and 1.
-1. So it gives me -3 minus 1 over 1 times -1 plus 5. If I did that right.
Yeah.
So -4, so that'd be +4 over 4, which gives me 1. So there's my slope, and I have a point. So y minus y equals slope times x minus x. So it'd be +1. So add 1. So y equals x plus 2. Pretty sure? Is that what you get? 1 times 1 is 1 plus 1 is 2.
Wait, what?
Oh my gosh.
Now, it will tell
Actually,
you.
Wouldn't it be 1 because you already have that 1, so it would be 1 plus 1 and then, 3 plus another 1.
No, because 1 times 1 is 1 plus 1 is 2.
And then you have to move the y.
I did move that over. That's this one. Okay, so guys, the calculus part right here, this is where we finish the calculus, yes? All the rest of this is a bunch of algebra that we have to get through. Which is going to be the hardest part, the calculus or the algebra?
Algebra.
Okay, so get your calculus, work on your algebra, and if we need to be working, we'll work. Our algebra is where we're going to have to take most of our time. Got it?
Yep.